Today, we're going to be talking about the changing states and density of water. So you'll be on a note sheet that looks just like this. Get your pencil ready. Make sure that you pause often to be able to write down all of the important ideas and draw lots of examples. Let's get started. Water goes through a lot of changes of state. But did you know it's the only substance on Earth that commonly exists in all three states? Take a second and see what you can come up with for examples of water in its solid phase, its liquid phase, and its gas phase. Pause the recording now and take a second to write. Now that you've had some time to write, maybe you came up with some ideas, for example, for solids. We find solid water in the polar ice caps, sleet, hail, icicles. Maybe for liquid, you came up with some examples like rain. We find liquid in lakes, liquid water in ponds, oceans, groundwater. Gases. We find gases in lots of places, but think about evaporation. We find it in water vapor in the air. We find it in clouds. I'm going to show you a brief video of the ice bomb. Now, as we watch this video here, I want you to take a look, and I'm actually going to talk through the video and fast forward some of it here as we go. They're going to take a metal bomb, a bomb casing. They're going to fill it up with water. She's going to fill it all the way to the top. Then they're going to put the cap on. They're going to put it on very, very tightly. After that, frozen solution of dry ice and acetone. Here she is putting the cap on. Okay, so it is full as it can get. When it goes in there, it will instantly freeze. Notice the blast shield around the outside, and they're also going to put a wooden box on top of it. So here it goes. What do you think is going to happen? Remember, it's just water inside a metal casing.
It takes a short time for the water to freeze. When it does, the bomb explodes.
Let's take a second and think, why did that happen? What is it that caused that to burst? Well, we know that when you freeze water, the water molecules actually move farther apart when the water freezes. It's that movement of the spreading of water molecules that caused it to burst. We know that this happens in nature all the time. Think about during the winter time. When water gets into small cracks in the road and it freezes, it thaws, and then it freezes, and then it thaws. And as this process happens, every time it freezes, it expands a little bit more. Eventually, it breaks the asphalt. When this continues to happen, a lot of times it forms a pothole. That's one of the reasons that we find lots of potholes in the spring, because of this freezing and expanding as water thaws. Now, water molecules are kind of unusual. Usually, we think of molecules when it gets cold moving closer together. Water's unusual because its molecules actually move farther apart when it freezes. The molecules of just about every other substance do move closer together, though, when they freeze. So let's take a look. So if we take a look here at water as a solid, we know that we're talking about ice. In the solid form, water forms a rigid structure. Rigid means very, very hard to move, very strong. And the molecules in a solid are close. But what happens when water molecules form a solid, and here you can see those oxygen and hydrogen molecules, okay, bonded to each other, and actually forms a crystalline hexagon type structure. It's a three-dimensional structure. What happens is when water's a liquid, the molecules are in constant motion. They're bumping, they're jostling each other around, and liquid water molecules never stay in place for too long. When the water freezes, though, and starts to get colder, the molecules slow down and they settle into their place. And they line up in these regular formations that you see as the crystal here. Now, for pure water, the temperature has to drop to 32 degrees Fahrenheit or 0 degrees Celsius for this to happen. Let's take a look at water as a liquid. Molecules in the liquid move much more freely. They take the shape of a container. And as you look here, you can see that the molecules here are moving around much more freely. We know that water will take the shape of anything you put it into. Let's take a look at water as a gas. Now, as a gas, we call water vapor. In water vapor, the molecules move very freely because there's nothing containing them. They actually spread out to fill a space. They're moving very, very quickly and all over the place. Think about an air freshener. If you spray some air freshener or perfume or spray deodorant, as soon as you spray that, that smell travels out through the room. It's an example of gas. Those molecules are moving very, very quickly and they're spreading out as far as they can go. Now, when you think about water as a gas, think about the water vapor, the steam that comes when you're boiling water to make mac and cheese. Now, water can actually become a gas in two ways. The first way is by boiling. When you're boiling, you're changing water from the state of a liquid to a gas. When we boil water, it boils at 100 degrees Celsius and 212 degrees Fahrenheit. Put a star next to this because this is very important to remember. So as more energy is added to the liquid, and in this case it would be heat energy, the speed of the molecules is increasing and the temperature will rise. At 100 degrees Celsius, the water boils and that state change from the liquid to the gas occurs. We're adding energy and those molecules are escaping the liquid and turning into a gas. Water can also become a gas by the process of evaporation. In this process, we also have water from a liquid to a gas. In this case, the molecules at the surface of the liquid are actually absorbing enough energy, and this is what changes them into gas. Think about this in the states of matter. Little kids. If you have some little kids, maybe 5 little kids, 4-year-olds, you're babysitting them, if you can contain them, they're a liquid, right? They're just moving around the room, all the doors are closed. Then you put the kids down for nap time, and you have 5 little 4-year-olds. They're sleeping. They have no energy. They're not moving. They can't escape. That's your solid. Now, imagine that you give the kids lots of sugar. All of a sudden, they're moving around. They're going everywhere. They're all over the place. All of a sudden, they become a gas, and they're trying to escape the room. When they escape the room and they walk out through the door and they run out through the door and you can't catch them, think of that as evaporation. You're giving them lots and lots of energy, heat energy, sugar in this case, and it gives them energy and they're able to escape, just as the water molecules would escape from the liquid in the pot of water you're boiling on the stove into the air as your gas, as it absorbs more heat energy. Then imagine you had that fast kid who just ran out the door, and by now the sugar's wearing off. All of a sudden, he starts to run out of energy. He comes back into his friends. He comes back down, and he turns back into a liquid. This is condensation. Which we're actually going to talk about next. But before we do that, let's come up with some examples of evaporation. Evaporation can happen in many different ways. Just think about, we're using heat energy, right? We're adding energy to something to cause the evaporation from a liquid to a gas. So imagine you're drying your hair with a hairdryer. You're adding that heat energy, your wet hair becomes dry, liquid to a gas. That water just evaporated and went into the atmosphere. Think about a puddle on a sunny day. That heat energy takes that liquid that was a puddle and turns it into a gas. Can you think of any other examples to write down?